All right, guys, in this video, we are going to finish up section 6.3 on our first little topic of conics, which is parabolas. So if you have not viewed the lesson or gotten the notes on how all this stuff works, then please make sure that you go back and view the first video. But this one is going to be the one where we're going to actually go through the examples. So anyways, again, make sure that you get the notes first with all of the background information. Yes, it is parabolas, but we're looking at it in a different way. So it's going to require us to have the background knowledge that was in the last video. So for here, it says we're going to find the focus, the directrix, and the focal width of our equation. We have y equals negative 1/3 x squared. First thing I want us to do is recognize, are we dealing with a parabola where the vertex is at the origin, or are we dealing with one where the vertex is somewhere else? And so what I want you to do is look at the format of this equation. Some of you guys may recognize from the way this is set up that it is kind of in vertex form. So you don't see anything added or subtracted in here. Meaning that it is going to be from the origin. If you forget that fun little fact, you can also reference back to our different equations that we had on our page over here. And the one it's more similar to is these ones where we had the vertex at 0, 0. Because again, there's nothing added or subtracted in parentheses with x or y like that. Okay, so if we recognize, first of all, okay, I'm going to just recognize here that our vertex was at 0, 0. So we know which set of equations we're working with. Also, I need to know, are we opening vertically, up or down, or are we opening sideways? So look at the value that's squared in this problem. X is being squared. If you look at our equations, the thing where x is being squared, that's where it's going to open up or down. If y had been squared, that's when we're opening left or right. So keep it up with that. So that already limits me to saying, okay, I'm working with these set of equations. All right, so my standard form of the equation is going to be x squared equals 4py. That means that the standard form for this would be getting x squared by itself. Right now it is not. So that really would be my first step, is to get that x squared by itself, okay? So let's take this and rearrange it. We have y equals negative 1/3 x squared. And for me to rearrange that, I'm just going to multiply both sides by a -3, and that should fix it. Right. So that's going to give me -3y equals, that cancels out, x squared. And if you want to swap the order, if you want to flip it around, you can. What's important to get from this is, in order to find our focus, to find our directrix, and find the focal width, in all of those, we need to know what the p-value is. And so that's what we're going to have to kind of work towards, is getting our p-value. This is in standard form for this type of equation. Okay, well, awesome. How does that equate to p? Whatever the coefficient is for y, that is 4 times p. So I want to look at what is in front of y in my equation and say, okay, well, that's what 4p is. And so that would allow me to solve for p. Okay, so I'm going to say, okay, this guy right here, this -3, that's what's in front of y. That is equal to 4p, okay? Which means that allows me to set up a little equation and find that p-value, which will then allow me to get the rest of what I need. So I'm going to say that 4p was equal to -3. That's a quick little just divide both sides by 4 situation. So I get that p is -3/4. So for me to give my focus, remember focus is a point. Okay, let's go back. For this setup, focus is going to be at 0p. Well, that means we're at 0, -3/4. For my directrix, we're going to be with that equation, y equals negative p. Okay, that means y equals the opposite of p, which is going to be a positive 3/4. The other thing I need is my focal width. All right, in order to get my focal width, that is going to be absolute value of 4p. So at the very bottom of that list of things, absolute value of 4 times negative 3/4. The 4 cancels out with the 4. Absolute value of negative 3 is just a positive 3. All right. So that was me getting all the things that this question asked us for. All right, let's go on to the next one. Example 2. They've given us another situation here. They said to find the equation in standard form. So the last problem had given me an equation. This one has not. This one has told me a directrix and a focus. And they want us to figure out the equation in standard form. So one important thing would be to try to know which way this is going to open so that we know which set of equations to work with. They did not necessarily tell me that my vertex was at the origin. So we have to figure out what's going on with that. And so honestly, one thing that I would do, especially like while we're getting started, is maybe just sketch what this looks like. Okay. Just real rough. It doesn't have to be fantastic. Okay. So just kind of off in the margins over on the side, I would just say, okay, let's just see what's going on. If my directrix is at x equals 2, I'm going to go 1, 2, and we're going to put a directrix, that little line right in there. Not an asymptote, okay? Don't view it that way, but that's just our directrix. And then they said the focus is at negative 2, 0. Okay. All right, so if that's what we've got going on, remember that your vertex should be halfway between the focus and the directrix. So my vertex should actually be at the origin, and we should be opening out sideways. Okay, so just in knowing that, that tells me my p-value is going to end up being negative. It also tells me that my vertex is at the origin. Okay. And then that starts to let me kind of like see what's going on. You can even see what your p-value is just by looking at this picture. It's actually exactly a negative 2 because from 0 to that negative 2, that p is negative 2. Okay. So again, there's multiple ways that you can go about it. You can even look at your directrix here and say, okay, well, if my directrix is x equals 2, then you could be like, okay, cool. If it's x equals 2, then that means it's going to be where my directrix is x equals. That falls into this category, right? Or the one, I don't know if it's going to fit on my paper, but the one over there where it's opening right or left at that. Could be that one. But since we can recognize that the vertex is at 0, 0, you could recognize that that was the one where it was x equals p. Or sorry, x equals negative p. And so that would be that 2 is negative p. So that p would be negative 2. There's multiple ways to go about kind of figuring out that value. So whatever makes sense to you, you can use that. All right. Now we have decided also it's opening left, right? So we're opening horizontally. We got a vertex of 0, 0. And that means I'm supposed to use that equation from our last page. Let's go back to it again. Opening right or left, we're using this equation right here. So y squared equals 4px. That's what we want. Y squared equals 4px. We just found what p is, which means that we get negative 8x there. And that's the equation they want. So really, I don't know if you've noticed, but that's kind of a running theme. Getting that p-value is one of the first steps in most of these problems, okay? All right, excuse me. Next one, we've got example 3. This one says to find the standard form of the equation, but they've given me a vertex and a focus. So this one, instead of a directrix, they're giving me the vertex. And I want you to notice that vertex is not at the origin, right? So this is the first time we're kind of branching into one of those translated parabolas. So if my vertex is not at the origin, right, they've given me the h and the k value for that vertex. I do want to kind of visualize what's going on. Are we opening up and down or left and right? So for those of y'all who have a really good, like, you can visualize this well in your head, you won't have to necessarily sketch something, okay? You'll just be able to kind of note if it's going to open horizontally or vertically. But for those of us who we don't always picture things in our heads, then I would say just, again, make yourself a little rough sketch. Doesn't have to be great. We're going to go 1, 2, 3, 1, 2, 3, 4. There's going to be a vertex. And then the focus is going to be at 5, 4. So 1, 2, 3, 4, 5, same height. Vertex was the first one. So this is going to be opening to the right because it always opens towards the focus. Okay, so that lets us know, since we're seeing here it opens right. Okay, we can even see what our p-value is in here. If you like to see it this way, you'll be able to see that your p-value is 2. Okay, if you don't like finding your p-value just by thinking of a graph, or maybe if your p-value is something really, really ugly, then there's other ways to calculate it, right? So I'm going to show you in another problem, I think, us doing that. But, well, no, I could do it in this one. Okay, so another way I could figure that out is if this is my focus, when we know that this opens right, then you can go back to your set of equations. I'll keep flip-flopping back to this thing. But you can go back to your set of equations. We said we know it's going to open horizontally, and we know that it's going to have a vertex not at the origin. Notice how the focus, the equation is h plus p k. All right, so look here. That means that this is h plus p. This is k. So if 5 is h plus p, and if h had been 3, then 2 has to be p, right? So you can get it algebraically too. You can get it by looking at your graph. You can get it algebraically, whatever works for you. The biggest thing is once we've recognized what p is, right, then we need to plug this into our equation. And so this equation is a little bit messier because it's the one where the vertex is not at the origin. We are opening horizontally, so we're just going to pull from the correct one. Okay, it's that top line for opening right or left. Okay, I'm going to rewrite it over here just so we have it as a reference. But it is the one that says y minus k squared equals 4p times x minus h not squared, right? The squared is only on one thing for a parabola. And then we're just going to plug in those values. Y minus 4 squared equals 4 times 2, x minus 3. And then we can just clean this up just a hair. I don't need to do a whole lot with it, but I am going to go ahead and at least multiply that 4 and that 2. Instead of multiplying all this, the 8 all the way through, I don't need to do all of that because we want it in the format where we can still see all of this stuff nicely. It's kind of the same format that you see that equation on our foldable on the last page. Oh my goodness, guys, I'm losing my voice. All right, we got 2 more examples to get through, and then I'm done with this video. All right, next one says use a graphing calculator to graph this. All right, so you want to have a calculator handy, calculator of choice. I will say that your NumWorks is going to graph this fine as long as you just type it in straightforward. I'll show you even. I had this typed in already. If you just type in on your NumWorks, ooh, that brightness is too bright. If you type in on your NumWorks just the equation, don't know if you can see that. Zoom in. Okay, so if we just type that in exactly how it looked, your numworks calculator will actually graph it. Sorry, my focus is struggling. There we go. Okay, so it will actually just graph it straightforward on your numworks. You're not entering it as a function. So when you go to type it in, when you add that element, you're not selecting the function one. You're going to select an empty one and just type it straight in. Okay, so the numworks calculators will do that. If you're working with a TI-84, they won't. So I need to show you what to do if that is the calculator you have. Okay. Okay, so example 4. I'm just going to make a note on here for those of y'all who consistently work with numworks. All right, so numworks will graph in this form. TI-84 will not, at least as far as I'm aware. Okay. All right, so if you're actually having to do this by hand, the easiest way, or not even by hand, but if you're trying to do it where you're trying to get it to where you can put it in an 84 calc, you're going to have to get it to where you have y equals, and that way you can put it in the TI-84s because it needs to be in that format. So what I would do is I would first square root both sides of your equation. That would just look like y minus 4 equals, and then you have plus or minus the square root of 8 times x minus 3. I want y equals, so I need to add that 4 over. So this would be 4 plus or minus the 8 x minus 3. And you could try to simplify that 8 out if you wanted to, but honestly, this is going to be good enough. So what you'll need to do is plot both y equals 4 plus the square root 8 times x minus 3. And you also need to do and the 4 minus. And if you plot them both, then it will still show up as the same thing. So let me show you. On the numworks, the one I have typed in is just the one as it was given to us, and it shows us this little sideways parabola. But if I go in there and I put the two separate ones, and I do enter them as functions, which is what your TI-84s would do. All right, we're going to have 4 plus square root of 8 times x minus 3. And then we need another one where we do the same thing, but 4 minus square root of 8 times x minus 3. Okay, so if I type in each one of those individually and then I look at my graph, okay, that red one got overlaid with one green one and one yellow one, and that shows you the two individual parts of it. That way it will graph. Okay, so then it had said to use a graphing calculator to graph them. We're going to kind of get that sketch. The vertex you can get even from just looking at the equation. That's going to be at 3, 4. That's our h and our k. 1, 2, 3. 1, 2, 3, 4. And we know this is opening sideways, and you could plot some extra points if you wanted to. Okay, it honestly is supposed to be hitting, it should be wider than that because it should be hitting 5 on the x-axis. But that would probably be best, is if I made it a little bit more precise. Let me get rid of this because we don't want to start off being lazy, right? Okay, so this is supposed to hit, if you look at your graph on your screen, you'll notice that it should end up hitting there. All right, I'll pretend that looks good. I can't draw very well, but anyways, there we go. You got your little graph. Fantastic. All right, last but not least, y'all. This one is using completing the square to rewrite our parabola in the standard form that we have been seeing for this section. So that standard form, we want to be able to write it in that format that we've been seeing from our notes, okay? One of those top ones. Now notice that on this problem, it is y that's being squared, which means we're going to end up hopefully with something that looks similar to this, okay? And we're going to use completing the square to do it. So if you've forgotten how to complete the square, you need to go and review that before we go through this. We are reviewing it in class, but just if you haven't been here, you need to go back and maybe search on YouTube, or I have a video, I think, explaining completing the square, maybe back in chapter 2, I think is when we did it. So you could maybe maybe before 2.2 is when I did the video. So you could look in that section, see if that's where I put it on Canvas. But yeah, so definitely check that out. But here is what we're going to do using completing the square to solve this one, okay? Or to put it in standard form as it asks. All right, notice which thing is being squared. That's the y, which means I need to work on completing the square with the y terms, okay? What I'm going to do first of all is I'm going to group it. Let me rewrite it, and then I'll start grouping it. Okay, so since I know y is the thing that's squared, I need to work on completing the square with y. I'm going to put all my y's together, and then I think I'm going to go ahead and just move my x term and the constant to the right side, because the way that the format is structured for these equations is like that. You have your y's on one side and x's and constants on the other. So that's what I'm going to do. All right, we're going to keep y squared. I'm going to keep the plus 2y. And then the other things, the 6x, we're going to move over, and that 13. All right, here's where the magic happens with completing the square. Well, number one, I have to make sure that my leading term is 1, which it is, so that's fantastic. Then I'm going to look at the linear term for the thing I'm trying to complete the square with. So I'm only doing that with y's because that's the thing that had a squared term. But I'm going to take this term, all right? We're going to take half of that, square it, and add it to both sides. So make a little note. We're going to say square half linear coefficient, and then add to both sides. Okay, just as a little note to what did I do here? This is what I'm doing. So half of 2, right? Half of 2 is 1. 1 squared is 1. So I need to add 1 on both sides of my equation. It has to happen on both sides, otherwise the equation does not stay balanced, right? But this is the magical step that completes the square, or allows us to complete our square. All right, negative 13 plus 1 is negative 12. Awesome. All right, now I should be able to factor this guy. Now, once you start doing this enough, you're going to start seeing the patterns as to how this works. But when you factor it, notice how these are going to be the same thing, right? Things that multiply to be 1 but add to be 2 has to be 1 and 1. And over here, I could factor out that 6 so that we can see it more in that standard form. I can rewrite this side as x plus 1 all squared, and that's equal to 6 times x minus 2. So they had said, write it in standard form. Done. But that's not all. They said also find its vertex, focus, and directrix, which means I need to find the p-value and then go through those other things. So my p-value we're going to get from looking at this 6. Remember that is equal to 4p, if you recall from our equation. So just to get our p-value, 4p equals 6. Divide both sides by 4 and then reduce that down. P is going to be 3/2. Okay, let's work on getting our values that we need, right? So to get your vertex is pretty easy because from the equation, we should just see the h is with x, the k is with y, and use the opposite sign that you see in the equation. So vertex is simple. That should be just 2, -1. But for our focus, I'm going to go ahead and set up where I'm going to answer these. And the directrix, we're going to have to do a little bit more work, okay? So in order to get the focus, I want us to remember what we're supposed to do here. This is opening sideways, right? And we have our vertex not at the origin. So knowing where to look in my equations is key. We're opening sideways, all right? And our vertex not at the origin. So we're using this guy and all of these equations on that far right. So for my focus, we're going to do H plus P K, all right? So I'm just going to kind of like block this off. Okay. So for focus, we are going to do H plus P K. Well, we do know those values. We just have to work on it. So this is going to be H, which had been 2, plus P. P had been 3/2. And then K was -1. That means we need to add 2 plus 3/2. So get a common denominator. 2 is the same thing as 4/2. And then we can add that 3/2 to that. So this is 7/2, -1. That is our focus. Okay? And then we need to get our directrix. So for our directrix, look again, directrix on that far right set of problems, the directrix is x equals h minus p. Okay? X equals h minus p. Well, we know h and we know p, so plug them in. 2 minus 3/2. Again, get a common denominator so that we can add these together or subtract them. And we get 1/2. X equals 1/2. Not just 1/2, guys. Don't just put the number. I need the equation. So x equals 1/2 for the equation of that line. And those are our answers. Yeah. Ta-da! All right, guys. That is definitely the hardest problem, but we got through it. All right. That is it for this lesson. I will see you guys in the next one. Bye.